All right, let's get started on day 2, unit 2, lesson 7. You're going to need your notebook, lesson book, and pencil, and we're going to be on page 60 and 61. Today we're going to compare functions with rate of change and initial values. So we're going to go in a little more detail. So I told you I was going to review little 6th and 7th grade, so let's get started. So in 7th grade and 6th grade, y'all did talk about proportional relationships. And one thing I want you to know that proportional relationships are very easy to see because of this right here. You have equivalent ratios, okay? So I want you to look at what I have and how this is a proportional relationship. So there's a few things that tell me it's proportional. But let's look at it in terms of y equals kx, where in 7th grade we talked about k being my y over x. Okay, so let's see how that looks. So here's my x and here's my y. Now, in 7th grade, you had nothing but proportional, right? And we talked about the proportional. Let me move this guy down so I can write under here. Okay. So let's go ahead and write our y over x, shall we? Listen to the words I'm going to use. I want you to give me an ordered pair, but I want it in reciprocal form. So I'm using some vocabulary words that I need you to know in 8th grade big time. I want the reciprocal. So I do not want x over y. I want the reciprocal of any ordered pair. Okay, so let's see what you did. Did you give me a 6 over 2? Did you give me a 12 over 4? Did you give me a 15 over 5? Did you give me an 18 over 6? Did you give me a 30 over 10? Look at my reciprocals. I flipped every one of them. I need y over x. We're going to really push this lesson as far as change of y over x. I want my y over x. Okay, now let's simplify each one of these fractions and see if they're equal. 6 over 2 is, yep. 12 over 4, yep, yep. Oh my goodness, they're all 3s. How do you know this is proportional? Because they are all equivalent ratios. That's exactly right. Okay, let's look at another reason why they're proportional. I know that a proportional relationship, watch this. So if I'm moving, remember just like we did on day 1, okay, how is my y changing? My y is changing by +6, isn't it? How is it changing right here? +2? I'll give you a second. Do you want to look at that one more time? Let me back up. Maybe I went too fast. How am I changing from 6 to 12? Think about the difference between those two. Can you tell that yes, we did add 6. Now, let's look at this one. How did we change from 2 to a 4? +2. I could put those in a reciprocal form also. That is how we can find our rate of change. It's the change of y over the change of x. So what's my change of y? 6, good. And my change of x? Oh my goodness, I still get a 3. Now watch this. I'm going to keep going, but I'm going to go backwards. So I'm going to go backwards 2 because I'm moving at the constant rate of change, and that gave me a 0. Guess what happens when I go backwards 6? Because that's my y change. Oh my goodness, I got a 0 too. Do you know the other rule of a proportional relationship? Has to be 0, 0, doesn't it? Dead giveaway. We're going to be using proportional relationships to help you with finding your initial value, and it also helps with your rate of change. And then when we get into unit 3, you're going to see unit rate and proportionality again. So I like to always bring things back and review, and they're going to help you when we get later. So, okay, so that is a proportional relationship. Let's look at a relationship that is not proportional. Okay, so let's talk about why this isn't proportional. So we're going to do the same thing we just did. I want reciprocals. So how am I going to do my reciprocals? What do we want them in? We want them in what? We want y over x. Okay, give me one. Okay, hopefully, did you see just this easy one right here? Let's do this one. Cool, 10 over 5. Ooh, simplify that one. Good, that's just a 2. All right, let's pull another one. And it doesn't matter which one we pull, does it? No, we'll do this one though. Let's get the reciprocal, 15 over 10. Notice it's y over x. Does that give me a 2? It doesn't, does it? This is a sure sign it's not proportional. They're not equal, so it's not proportional. But it doesn't mean that we still can't have a constant rate of change. Okay, so we are going to look at how to find the rate of change with our functions today too, okay? And one thing that we're looking at is we're going to talk about the change of y over change of x, okay? So in your, and let me switch slides because I want that one to come first. So in your notebooks, I want you to pause my video and I want you to write down the rate of change. Your rate of change is your m, okay? And we're looking at the change of y over the change of x. You can also write down our little 7th grade skill, which is our constant of proportionality, is our y over x. Keep in mind it's a k in 7th grade because you don't have an initial value. In 8th grade, because we do have an initial value, then my m, it's not going to be constant. So it has to change. That's why we call it the rate of change, okay? It's the rate of how it's changing, but it's not proportional. All right, pause my video and write this down. Okay, so now that we have the change of y over the change of x, we're going to look at some different forms and how we can change, okay? So if I go back to this one, let's just find this rate of change for fun, shall we? So I'm going to put my m, because we know now it's not proportional. I can't use a k. So let's look at my y first. How am I changing going from 10 to 15? And if you needed to use a calculator, that's fine too. Did you say 5? Because I'm adding 5. Nice. How is this one changing going from 5 to 10? Yeah, plus 5. So look at this. What is your rate of change? Did you say 1? Good, because 5 over 5 is 1. This is finding our rate of change. Simple, right? Yeah, y'all are doing great. Now, if I go backwards, as long as I can get x to have a 0, I'm going to find out what my initial value is. So if I'm moving by 5, can I move down by 5? Wouldn't that give me a 0? It would. And then what happens when I go down by 5 here? There it is. So this helps us find our initial value, or we could use our rate of change knowing it means to multiply, okay? Knowing it means to multiply. And I can say, well, 5 times 1 is 5. And then how do I get from a 5 to a 10? What do I add? I'm going to add 5. Let's see if that works for all of them. 10 times 1 is 10, plus 5 is 15. 15 times 1 is 15, plus 5 is 20. So that's another way of finding our initial value, okay? So let's do a little practicing with initial value. Okay, so initial value, if x is 0, then this number right here is my initial value. So if y'all want to pause my video and go ahead and write down this little trick, that'll help you. And we'll go over a few examples, on how to find our initial value throughout the next couple of days. So what's my initial value? 2. Exactly. I'll do one more. What's your initial value? Okay, so if I went up like this, notice, what are we starting with? We're going to start with 8 before we start adding 1, huh? That is what our initial value comes in. What do we start with before we use our rate of change? Okay, are y'all ready to move on? Y'all ready for a word problem? All right, here we go. A biologist studied the growth of 2 different trees over a 5-year period. At the beginning of the study, she measured each tree's diameter. The biologist took this same measurement each year to determine the growth. The red maple in her study had a starting diameter of blank. The diameter grew at an average rate of blank per year. The graph on the right shows the growth rate of silver maple tree. Which function has the greater rate of change? Okay, so what I want you to do, I want you to write down in your book all the things that you can come up with that are very important for this problem. I'm going to read it one more time. A biologist studied the growth of two different trees over a 5-year period. At the beginning of the study, she measured each tree's diameter. The biologist took the same measurements each year to determine the growth. The red maple in her study had a starting diameter of blank. The diameter grew at an average rate of blank per year. The graph on the right shows the growth rate of the silver maple tree. Which function has a greater rate of change? Pause my video. 3, 2, 1. Let's see how you did. Okay, so we have two trees. So did you figure out we have two trees? We have the silver maple, which is over here. We don't know anything about that one. And then we have the red maple, which is right here. Okay. Did y'all recognize the red maple is going to have a starting diameter? Okay, so what do you think this is going to be representing? The rate of change or my initial value? Okay, I hope you said my initial value, right? Let's use a bright color. My initial value is going to be there. And look, an average rate. So guess what this one's going to be? Good. Oh, good. There's my rate. Okay. What is the ultimate question? The ultimate question is who has the greater rate of change? All right, guys, are you ready to reveal the information? All right, here it is. So, my red maple has a starting diameter of 4 inches, and the diameter grew at an average rate of 0.3 inches per year. And there's your graph of the silver maple. Pause my video, and I want to see, can you figure out who has the greater rate of change? 3, 2, 1. Okay, let's see. Let's see what you did. So just with the words that we have for our red maple, let's pull out our rate of change. The average rate, did you pull out 0.3? And did you pull out my initial value was 4? Notice I'm using these letters, and I need you to always use these letters to keep in your mind. Your initial value is your B. That's what you're beginning with, what you're starting with. And then your M is your rate of change, okay? It's what you're multiplying by, what's happening multiple times each year, each cookie, per person, all those good things. Okay, let's look at this graph. So what is my initial value for that graph? Do you remember what we talked about day 1? What number is between 2 and 4? Okay, so hopefully you saw that that was a 3, but you might have been thinking, how is it moving? How am I changing of y over change of x? Remember we wrote that down today, change of y over change of x. Well, let's try something. Let's put them side by side. Okay, so here's a table that we have, okay? And so we graphed, and let's see if we can make some of these graphs bigger. I'll make this one bigger so we can see it better. Okay, there we go. So we know that this rate of change is 0.3. Let's see if we can figure out our silver maple. Did y'all get a chance to look here and here? Remember, I'm all about trying to find the close intersections that are immediate, like right at the stoplights, if you will, you know? And so I know that this is a 3. I want to focus on my y over my x, okay? My change of y over change of x. I'm going from a 3 to a 4. So how did I change from a 3 to a 4? I went up 1. My vertical change is 1. Now let's find my horizontal change. So I'm going from a 0 to a 2. Always look at your numbers on your graph. Don't just think I'm going 2 blocks over, because if I'm counting for 2s and 3s and 4s, it's going to change your outcome. So be very careful with the numbers on your graph. So I'm going over 2. Look at this. That's 1/2. Okay, and we're about to compare it to a 3/10 decimal. Can we convert 1/2 to a decimal? Absolutely. What is it? Did you say it's 0.5? Yeah, okay, so who has the greater rate of change? 3/10? 5/10? Yeah, the silver maple has a greater rate of change, right? Okay, what about our initial value? What does that mean, the growth rate? What does that mean? Are you thinking that it grows faster? Yes, it grows faster in inches than my red maple. That's what my rate of change is how fast or how slow the rate changes per year, per day, per person. Okay, definitely. Who had the higher initial value? Good. The red maple had a 4 and my silver maple had a 3. Good. Okay, guys. All right. So let's try one on our own. So in your notebook, in your lesson book, I'm going to read it and I want you to pause your video and answer. The table and the graph show how much money a store earns selling each team t-shirt and each team cap. Compare the rates of change for these two functions. Pause my video and compare the rates of change. 3, 2, 1. Okay, let's see how you did. So let's talk about the t-shirts. Let's look at our rate of change for the t-shirts. Did you try to find the change of y over change of x? Let's see, +4 and +1. So y over x would be a 4. So did you get 4 for the t-shirts? I hope you did. Okay, let's look at the rate of change for my graph. Remember, my cap is still going to be y over x, okay? And just like you did in 7th grade, both of these were actually proportional. Because if I don't buy t-shirts and if I don't buy caps, I don't owe anyone money. So, and this little guy starts on a 0, 0. I'm going up 2, and I'm going to go over 1. So my rate of change is 2. So compare the rate of change. And what do they mean? Well, did you say that the t-shirts is a rate of change of 4 and the number of caps is a rate of change of 2? Did you say that t-shirts is times 2 the amount of caps? Ooh, that's a good one. It's $2 more per t-shirt than cap. Oh my gosh, there's so many things we could say, huh? Okay, but this is the end of day 2. So we are starting to get into comparing different functions. And tomorrow we're going to add a little more. So good luck, and I will see you tomorrow, guys. Bye.